Okay? The commonest type of, we mentioned that the fibers are of three main types. What are these three main types? Collagen fiber, yellow elastic, and reticular fiber. Now, the collagen fibers type 1, which are the white collagen fibers. They appear whitish, white in color, just like tendons, just like ligaments, because they are rich in collagen fibers. You have to know the tissue and you have to know the size. Collagen is the most abundant protein in the human body. Collagen fibers are synthesized by fibroblasts in connective tissue fiber. I have to ask you, what do you mean by blast cells?
Information?
Cells which can grow in size and secrete. Active cells, but we call fibrocytes inactive, resting. So now do you know the difference between blast and cyte? Blast can grow and secrete, active. Cyte, when you hear fibrocyte, it's inactive and non-secreting. In connective tissue, who forms the collagen type 1 fibers or the white collagen fibers? Fibroblasts. The fibers also are present in bone. Bone is rich in collagen. Who forms collagen fibers in bone? Osteo means bone. Blast is the active cells in bone. Active secretory cells. Odontoblasts. What are the odontoblasts? Cells forming the dentine of the tooth. The tooth is forming of dentine covered by enamel at the surface and covered by cementum at the sides. Dentine forms the main mass of the tooth. The largest mass in the tooth is formed of dentine. The dentine is rich in collagen. Which type of collagen? Type 1. Which are the white fibers. Who form collagen in fibers in the dentine? Odontoblasts. Now, the protein of collagen or the collagen is formed of molecules. What do you mean by molecules? The smallest unit of structure. These are the molecules from which the collagen fibers are formed. It is formed of 3 chains of amino acids. This is 1, the second, the third, forming a helix around each other. When these molecules come beside and arrange over each other, they form collagen fibrils. When the collagen fibrils collect, they form collagen fiber. When the fibers collect, they form collagen bundles. One more time? Yes. One more time. Okay, let us take a picture, but let us read it. Collagen is formed of protein polypeptide molecules. Each is composed of a chain of 3 amino acids. These are the amino acids present. It's biochemistry. I don't need it. Each protein polypeptide chains are wound together in the form of triple helix. Triple 3. Helix formed of 3 amino acid chains. This molecule is called trophocollagen molecule. So what is the smallest structure in the collagen fiber? Robocollagen molecule. What is this molecule? A helix of 3 chains of amino acids twisted around each other. Let me say one more. If there is a change in the size of amino acid or the type of amino acid in any chain, it leads to a congenital disease. What is the most famous collagen disease? Ehlers Danlos syndrome. الرجل الكاوتشوك. ايه؟ الراجل المطاط. ادي جلد اهو. جلد مكون من ابيديرمس تحديد under the epidermis is dermis. Dermis is formed of dense irregular connective tissue rich in collagen fibers. I will pull my skin. Not more than that. In Ehlers-Danlos syndrome, whoa, the skin is stretchable. The bones, the joints are connected by ligaments. So this is the knee joint. You can bring the knee joint, the foot up in this direction and put it behind the neck. So, what is an example of collagen disease? Ehlers-Danlos syndromes. ثاني. It's ready. But I talk about by chance. You will find it in diseases of collagen and diseases of elastic fibers. So forget about the name right now. It's ready. يعني اللي هو الراجل المطاط ده راجل عيان، راجل غلبان، ما هياش قدرات خارقة ويكتبوا لك للقمة العيش. Okay, who forms the collagen, the protein of collagen in site connective tissue? Fibroblasts. What is the site of formation of protein which will be secreted? It's the rough endoplasmic reticulum. The protein formed there is transformed to Golgi complex through transfer vesicles. The Golgi complex may modify, concentrates, and divide. Surround the protein formed by membrane, and this is called secretory vesicle. The secretory vesicle go to the surface and then release the protein forming. Next, this protein, which is a tropocollagen molecules, will be arranged in a special way to form first fibrils. And after that, the fibrils form fibers. And the fibers form bundle. Can you? Hi. Yes, I mentioned it. This is a fibroblast which forms collagen fibers in connective tissue. The nucleus sends orders to the rough endoplasmic reticulum to form the protein. It's a protein, 3 amino acid chains, which make a helix. To the rough forms a protein responsible for the protein which will be secreted. Transferred, the synthesized protein is transferred through transfer vesicles to Golgi complex. Golgi complex may modify, concentrate, and then surround the protein which will be secreted by a membrane. This structure is called secretory granule or secretory vesicle. It goes and opens into the surface, delivering the tropocollagen molecules to the outside. Clear? Okay. Here, this is an alpha chain, one alpha chain. 3 of it will form a helix to form thrombocollagen molecule. The helix, this is thrombocollagen molecule. Each one of these is a molecule. They are arranged in rows with areas of overlap. I don't like to remember this. But finally, its arrangement by the electron microscope will give rise dark areas, pale areas, dark areas, pale areas. We call it axial along the axis. Striations, lines. Dark underline, dark underline, dark underline, underline lines. Okay.
دكتور
Let me finish it.
يقدر يحرك من هنا ايش يروح
The collagen. So we start by thrombocollagen molecules. These molecules will form fibrils. The fibrils will connect to form fibers. And the fibers will connect to form bundles. So and this forms a tendon. So what is the structure of tendon? Bundles of collagen fibers, separated by the masna, separated by the factory, with fibrosites in between. Because the fibroblasts, after secretion, it changes to resting cell, what we call fibrosite. So the structure of tendon is formed of parallel bundles of collagen fibers with rows of fibrosites in between.
structure of what?
You have a question?
Structure of what?
Structure of tendon again?
Tendon. Yeah.
We'll come to it later. Types of connective tissue.
Bundle of what? Oh, that's structure of tendon. Bundle.
Collagen fibers in the fresh state appear white in color, just like tendon fibers. Histological appearance. The collagen fibers are thicker than the elastic and are thicker than the reticular fibers.
Oh, bundle.
When they appear in tissues, they usually collected, form bundles. When you see the bundles, you see that it's wavy. Fiber, bundle. This bundle is wavy. The wavy bundle may branch. When it branches, some of the fibers go in this direction and the others go in this direction. So what branches? The fiber or the bundle? But not the fiber. So collagen fibers are non-branches. But they form bundles. And the bundles may branch. Some of them go to this direction and the others go to the other direction. The collagen fibers are thick, non-branching fibers. Bundles of collagen fibers appear wavy and branching. They are not stretchable. Resist stretch. So they are tough. قوية. عشان كده بحطها في التندون. So it is present in tendons. It is present in ligaments. To resist stretch. Limit the movement in ligaments. They are moderately acidophilic. What do you mean by acidophilic? They like the acidic stain. What is the most common acidic stain? Is eosine. We have the common stain hematoxin and eosine. What takes eosine appears pink to red. What takes hematoxin appears blue to purple. أزرق بنفسجي لأزرق. يبقى الكولاجين فايبرز تظهر ايه؟ اسيدوفيليك ولا بيزوفيليك؟ اسيدوفيليك. تظهر بينك تو ريد ولا تظهر بلو تو بيربل؟ بينك تو ريد. اوكي. appear blue by memory, forget about. appear green by massive trichrome. In some of our sections, sometimes you see the collagen fibers are stained blue, and another section the collagen fibers appear green. Why? the different stain. Mallory stain give blue color. Mason trichrome give green color. Forget these, but don't forget EUC. Here. What is this? What we call this? It contains acidophilic fibers or not? Do the fibers run in one direction or in different directions?
Different.
So what we call it? It is rich in collagen fibers. So we call it dense. If the connective tissue is rich in fibers, we call it dense. What next? Dense irregular. What next? Connective tissue. This is by hematoxin and EUC. This is a bundle. The bundle is formed of collagen fibers. The fibers of the bundle branch. Some fibers go in this direction and the others go. But the single bundle is wavy. This is by another stain, which is Mallory stain. But forget about the Mallory or trichrome. Happy vein or hematoxin? What is this picture? This is by electron microscope. And the other one by scanning the electron microscope. What do you mean by scanning? Just a surface. So the tissue contains bundles of collagen fibers. And these are mostly elastic. The thin ones are elastic or reticulum. Now, what are these? Fibrils, which you see dark light, dark light, dark light, dark light. In electron microscope, we call it axial periodicity. Period and period. Darker light, darker light. Another. Fibrils in a longitudinal, cut in a longitudinal direction and cut it in transverse. What do you see here? Dots. What are these dots? Okay, the molecules. The molecules which form the fibrils. Types of collagen. We have multiple types of collagen. Depending on the arrangement and the type of amino acids in their alpha chains. The types and the arrangement of its amino acids in the alpha chains. Type 1 collagen, which is called, which forms collagen fibers. Ordinary collagen fibers, type 1. If collagen fibers, the white one, are type 1 collagen. Present in tendons, present in ligaments, present in bone, present in dermis of the skin, and in teeth. Type 2. Cartilage is a type of connective tissue containing cells, fibers, and matrix of ground substance. Do the ground substance contain fibers? Yes. Which type of fibers? Collagen. But type 2. What are the type of collagen in cartilage? Collagen type 2. This is in hyaline cartilage. Because we have 3 types of cartilage which differ in the type of fiber content and differ in the ground substance present in between the cells and the fibers. So collagen type 2 present in hyaline cartilage. Type 3 forms fibers called reticular fibers. Its function is support of parenchyma cells. mentioned this last time, right or not? يبقى في حتة تانية. قلتها في حتة تانية. Okay. This is a reticular fibers for are thin, and the thin are branching, and the branching are anastomosing. So they form a network. Repeat again. Reticular fibers are thin. The thin are branching, and the branching are anastomosing. They meet each other.
Okay.
To form spaces in between. Who occupy, who is present in the spaces of network and supported by the reticular fiber network. Parenchyma cells. يبقى انا قلتها.
Yes.
مش كده برضه؟ بتاع دلوقتي ولا المره اللي فاتت؟ المره اللي فاتت. شفتوا بقى؟ Parenchyma cells. Give me example of parenchyma cells. Hepatocytes, lymphocytes, adipose cells. Very good. Okay? Bone marrow. Bone marrow. Who support the cells which are formed in the bone marrow? Reticular connective tissue. Type 4 is present in the basal lamina or basement membrane. Remember, basal lamina or basement membrane. What is the basal lamina or basement membrane? Present under epithelium, which supports the epithelium, and it has other functions. We'll mention it in connective tissue. Type 5, blood vessels and placenta. We have more, but these are the most common types. We have more types of collagen fibers. Reticular fibers form branching and the anastomosing network can be demonstrated by silver stain. Appeal brown, forget about that. By electron microscope, collagen fibrils show the axial periodicity. Not important, not important. They form the supportive network of parenchyma organs, just like lymph nodes, spleen, liver, bone marrow. Gives them support and their special distribution there. What is this? Reticular fibers. Give me a very good site here. Thin, branching, anastomosing with spaces. These spaces are occupied by cells of the organ. Stained by silver. The silver demonstrates the network but does not demonstrate the cells of the organ. You see this structure? It's rounded. So, the liver cells, what is the shape of the lobules in liver? Hexagonal or pentagonal? Hexa has 6 sides. Beta has 5 sides. With a central vein in the center. خدتوهاش في البيولوجي؟
No.
ولا في المدرسة؟
No.
طب ما أنت عارفة عربي أهو. Hold it. Okay. Ehlers-Danlos syndrome. Syndromes. Because I mentioned the change of the site or the type of amino acid in the helper chain give a disease or change the character of the collagen fibers. It is no more tough. It becomes stretchable. Ehlers-Danlos syndromes characterized by abnormal skin laxity. شد جلد كده وهاتوا شد ربع متر قدام لغايه هنا. hyper mobility of joints. الني joint يرجع ورا but cannot go up. هو يقدر يجيب رجله في الاتجاه ده ودراعه يجيبه كده يلفه حوالينه او يلفه بطريقه غريبه. Disease caused by mutation in a collagen gene in an enzyme related to collagen metabolism. أو في التركيب بتاعته. It arises from deficiency or a change of position or replacement of one amino acid by another amino acid. يبقى دي إيلر دانلوس syndrome. الرجل الكاوتشو. Elastic fiber system. سمعتوا عن مرفان؟ Do you hear about مرفان syndrome؟ ما خدتوهوش. طب شفتوا واحد طويل his chest and abdomen are small while his arms and legs are tall? And he's afraid of rupture of aorta?
Where?
Rupture of aorta, where the blood pressure is high, because the whole blood is pumping in one time to the aorta. So the pressure in the aorta is high than everything where in the body. Marfan syndrome is a disease due to abnormality in elastic fiber formation. But let us see the structure of elastic fibers. Don't forget that this man can get ruptured aorta and it's killer at any time. The aorta, boom.
Okay, what is the name of the disease?
I'll tell you later.
We want to.
Elastic fibers, the second type of fibers. Why we call them elastic? Stretchable.
Extension.
And the stretchable ones can recoil.
Oh my god, anatomy عارف.
But the collagen fibers, not. The reticular fibers are weak, but support the cells of parenchyma organ. We have, you hear about elastic fibers, but you don't know that there are 3 types of elastic fibers, which differ in its structure and differ in its function. Differ in its structure and differ in its function. Okay? Now, oxydanan fibers, which is the simplest type of. Let us go to the elastic fibers and then return back to these. Let us go to the simple type, which is the most common. Elastic fibers. Number three is the types of elastic fibers. In the fresh state, appear yellow in color, as I mentioned. In the ligamentum nuchae, in the back of the neck. Ligamentum flava, in the back, in between vertebrae of the back. Yellow elastic fibers give the tissue a yellow color, but while the collagen fibers give the tissue a white color. They appear yellow in color, they are stretchable but regain the original length. This regaining we call recoil. Forming of 2 types of protein, elastin and the microfibrils. In the last lecture, I remember, I told you the elastic fibers are formed mainly of elastin. And I told you, when we mention mainly, there should be something else. What is the something else غير the elastin protein? Microfibrils. Now we go to any stretchable elastic band you buy it. أستك أنت بتشتريه. الأستك ده مكون من كام حاجة؟ من حاجتين. Any elastic stretchable substance you buy it from anywhere It is formed of two things. Caoutchouc, together with threads. Threads of what? Of cotton. The cover or in between the elastic fibers. Why? To give it support and strength. So, the elastic fibers are formed mainly of elastin protein, together with microfibrils, which give strength to the elastic fibers. What happens in Marfan syndrome? Elastin is present, but the microfibrils are deficient. So, the elastic fibers can extend more. With more extension, it's easy to be cut. So, this is the cause of rupture of aorta in case of Marfan syndrome, where there is a deficient formation of microfibrils of elastic fibers. Synthesized by fibroblasts in connective tissue, smooth muscle cells in arteries can synthesize the protein of artery. Whatever it is, collagen, whatever it is, elastic, whatever it is. So, what are the functions of smooth muscles? Number one, contraction. Number two, secretion. Secretion of proteins. Proteins of what? Connective tissue fibers. Where the smooth muscles are rich and the connective tissue is small. Just like arteries. Chondroblasts in elastic cartilage. We here have elastic cartilage, which you can bend and return back. This elastic cartilage contains elastic fibers. كان المدرس زمان كان بيشد وداننا لو احنا مش شاطرين. صح؟ بقول لك ودانك طولت من كتر ايه؟ شد الودان. ولو ان هي دي كونجينيتال او حاجه كونجينيتال مش مشكله. يبقى where we can find elastic fibers? Ligaments, yellow ligaments. Where else? In arteries. Where else? In elastic cartilage. By light microscope, they are thin. أرفع من thinner than collagen. Straight and not wavy in section. And branch. By hematoxylin, they appear mildly acidophilic or pale acidophilic, pale pink in color. Stained by special stain to demonstrate or thin stain. Not important for me. Or get a stain. Forget about it. By EM, no axial periodicity, just like collagen. No axial periodicity, and I'll see you next picture. The fiber is astic. Remember, astic. The fiber is formed of a core of elastin protein in the center, surrounded by a sheath of microfibrils. So the microfibrils will act as a whitish color for the astic. And this gives the astic its support. Avoid overstretching because overstretching will cause rupture. Elastic fibers have no axial periodicity and are not made of fibrils. I think, what is this picture? what is the type of fibers do you see? Thin or thick? Thin. Straight or wavy? Branching or non-branching? Branching. So these are elastic fibers under the microscope. Elastic fibers, okay. One thing, but actually forget about except in Marfan syndrome. Microfibrils are formed mainly of the protein fibrillin. In Marfan syndrome, the formation of fibrillin is deficient. And I told you, fibrillin give microfibrils, which are formed of fibrils, gives strength to elastic fibers. Overstretch of it, it will resist overstretch, okay? But with the absence of fibrillin or microfibrils, can rupture, just like rupture aorta, in which case Marfan syndrome. Here, these are the elastic fibers by light microscope, and these the elastic fibers by electron microscope, but drawing. What surrounds? In the center, there is elastin, the white areas, surrounded from outside, and present inside microfibrils to give the elastic fibers strength. They can distend and recoil, but not overstretch because it will rupture. If no microfibrils, rupture occurs.
Strength. To give to what?
Marfan syndrome. Due to absence of fibrillin which interacts with elastin in tissues. The two share in the formation of elastin. Elastin for stretch, microfibrils to resist excessive stretch. Patients are usually tall, طويل, have a very wide arm span. ايديه توصل لهنا كده، بس طبعا هو مفروض. يعني ايديه اهي، هو ايديه توصل لتحت، ورجليه طويله، لكن الترانك بتاعه but the trunk is short. It's short. The trunk is short. The arms are long. The legs are long. Because that where connective tissue is present, it contains elastic fibers, even bone. Even if it was in small amount. And the presence of deficient elastic fibers give a more development for the bone in this case. Patients are usually tall, have a very wide arm span, and are prone to develop subluxation of the eyelids. هقول لك في الايلينز وارجع لك اللي هي المايكروفايبريلز اللي هي النوع الاولاني من الالاستين او ستلام فايبر. مين هي اللينز؟ What is the lens? Of the eye. It is connected to some what we call ciliary body by fibers. These fibers are the micro, the forming of fibrillin. The microfibrils, the fibers which bind the lens to the ciliary body, when they pull the lens becomes thin for far vision. When it becomes relaxed, the lens becomes thick for near vision. If the protein of this fiber is deficient, it will lead to subluxation of the eyelids. The eyelids will be redundant, not pulled to be thin and not relaxed to be close. Will be redundant. So in Marfan syndrome, these are the case. Growth of long bones need fibrillin, hence bones grow longer in its absence. Patients are also prone, liable, may usually to develop rupture of aorta. And I actually searched for a picture for Marfan syndrome, but I didn't find with me. Now,
I think the time is out.
wait. Now, 2 minutes to go. Or do you want it in the next lecture?
Yes!
Don't forget this. Because I will jump into the next subject. Do you have any question?
No.
Yes.
One. He was before and he.
Ladies first. Sure.
Okay, then. He's polite.
That's good of you.
Yes. What? The lens? It's a character. It's a protein. When you know any stretch, any rope stretch you use it. It's a character. It's a protein. The lens is a protein. It's a character.